In this set of demos, we are going to understand the structure of a netcdf file. So once you log in on the cluster, we're going to go in the directory ROMs mapping as we're going to use these netcdf files to load data that we are eventually going to use to do some mappings. So in this directory, you'll find 1, 2, 3 netcdf files. So the first thing to understand is that a netcdf file is a self-explanatory type of data file. And if you're logged in on the cluster, you can explore the content of a netcdf file using the netcdf command, and then pass as an argument the name of the file. We're going to look at this, but we're going to use the pipe more so that we're going to look at the structure of the file one part of the time. So let's do netcdf. The first thing that you find in a netcdf file typically is that a netcdf file has some dimensions, or if you like, you could think if you had a grid of a model, it would be the size, of the grid. And so in this case, it has 180 points for a dimension called lon, which is part of the longitude, and 89 points for the latitude. Then it has this other dimension that is equal to 2, and then it has the time dimension, which is equal to 1842. Once you have these dimensions, then the netcdf file you can define variables. So for example, the first variable here is going to be latitude, and latitude will have dimensions of lat. Okay, so in this case 89. In addition to having this, however, the netcdf file is self-explanatory, so you'll find that there's also indications of other fields like the units, in this case degrees north, the long name, the actual range, the standard name, the axis, and so forth. If we go further down, this is a sea surface temperature file. You find that there is a variable now called sea surface temperature, and this variable has dimension of time, lat, and lon. So it's a 2D array with the time dependence. And you can see that associated with this particular information, you have, other subfields for these variables that tell you, the long name, which is the monthly means sea surface temperatures. It tells you the range, the units. It also tells you that sometimes these variables may have an offset that you have to add, in this case is 0, or a scaling factor. So for example, in this case you have a scaling factor of 0.01, which means that when you load this sea surface temperature field, you have to multiply it by 0.01 to get the actual units of degrees. It also tells you that in this case there's values that are not defined, and these missing values are given a certain number, which is this particular number here, and then it tells you other information. So we're going to start. So this is one netcdf file. Another example of a netcdf file is one of the model outputs of the ROM's model output, which I have linked here in turquoise. I can do more on that. And so again, here you see that there's a lot more dimensions, which are associated with the various types of model grid, the row grid, the U grid, the V grid, the stream function grid, and so forth. And you have things like, for example, the SRAW, which is the number of sigma levels, which is 30. And you have a whole bunch of variables here. In this case, there's a lot of them because the model output is very rich. And you can go down, and towards the end you'll start seeing variables like the longitude, the mask, and now here it becomes the state variables of the model become big start. So you have U bar, V bar, and so forth. The U, the V, the omegas. The omegas are the average S coordinate vertical momentum component, and so forth. Towards towards the end, you can also have some global attributes. In this case, this average file says, this ROMs file says it's an average file. It tells you what type of convention is using, what type of application, in this case the Northeast Pacific, and then it tells you a whole bunch of other things that you're interested. If you keep going with the netcdump, at some point you'll have that the name for each variables, you're going to actually have the actual value. So for example, these are some of the variables that are stored, and you can find the values for these variables. So this is, for example, topography H, and if you go down you can see that there's a varying topography here, and so forth. So this now becomes a very long file. So in general, if you want to actually load a variable from an netcdf file, you don't do it using the netcdump command, but we'll do it in MATLAB. So in the next demo, we'll learn how to read a netcdf file in MATLAB.